A great example of a problem-solving question on this upcoming unit test is problem number 40 on page 132. We are asked to solve for x by completing the square. So we have the expression kx squared minus 2x equals k. And we know that the vertex form or the perfect square form of a function is a x minus h squared plus k. Keep in mind that the k in the vertex form of the function is not the same as the k used in this equation, so please do not get confused. Well, we learned that h is negative b over 2a. Well, in my case, we have negative, b is negative 2 over 2k. Well, I can reduce the 2's, and since we have a double negative, h will be 1 over k. Now let's find the k in the vertex form. So again, do not get confused with the same k in this expression. Yes, I agree, the textbook could have used another letter than k. Imagine it's a, if it really creates some confusion for you. So wherever we see x, we are going to substitute the h value to find the corresponding value of the vertex. We have k times 1 over k squared minus 2 times 1 over k. And I know some of you will now stop because you're going to say, well, it equals to k. Well, no, it's not the same k. So in this form of the quadratic equation, you might want to express it in standard form, which is kx squared minus 2x minus k equal 0. So in that case, we have over here one more minus k. So let's see, we have k times 1 over k squared minus 2 over k minus k. We can reduce the k's. Now, if you do remember from unit 1, we can reduce the variable as long as it is not equal to 0. So we can even state our restriction right away. K must not be equal to 0. So we're left with 1 over k minus 2 over k minus k. We do have to bring all three terms to the same denominator, and since it looks like the denominator is k, we have to multiply the last term with k. So we have 1 minus 2 is negative 1 minus k squared over k. Now let's look at what my equation will look like in vertex form. Well, a was k, so k times x minus 1 over k squared minus, and we can really pull this minus in front, 1 plus k squared over k equal 0. Well, we did learn that we have to move the k on the other side and isolate the two variables. So we have k times x minus 1 over k squared equals to 1 plus k squared over k. We still haven't isolated completely the perfect square. We have to divide both sides by k, which means that x minus 1 over k, oh, I apologize for that, squared equals, and when we divide, we're going to get a k squared in the denominator. 1 plus k squared over k squared. Now we will square root both sides of the quadratic equation, and we have x minus 1 over k equals plus or minus, well, when I square root the numerator, because it is a complex number, there is nothing for us to reduce or simplify. So we have radical of 1 plus k squared, and radical of k squared can be written as k, as long as you remember that restriction, k cannot be 0. The last step is we're going to move the h onto the other side. X equals 1 over k plus or minus radical of 1 plus k squared over k. And since we have seen the quadratic roots having one denominator, we can rewrite it as 1 plus or minus radical of 1 plus k squared over k. This is not a particularly difficult problem. However, because of the variable that the textbook has chosen for us and the k in the vertex form of the function, I can see how some of you might get confused as to how to solve it, how to set it up. If you do remember to go back to the beginning and make sure you set it up in the beginning in standard form, and try and ignore the k in the vertex form and the k used in its quadratic equation, you will be able to complete it. If, let's say, you see more problems like this one, choose another variable. Say that k is a, or p, or n, or m, and that will allow you to solve for the roots of this quadratic equation without worrying that you're going to make mistakes.